Bismillahirrahmanirrahim. Assalamu alaikum. Welcome to my YouTube channel, Diversity of Plants Zone. In this channel, you will get every information related to the plants and their diversity throughout the world. Before starting this video, I request you all to please subscribe my YouTube channel. This channel needs your support in the form of your feedbacks, comments, subscription and likes. Today's topic of my video is about morphology of root. Today I will discuss its part 3. I hope that you will enjoy this video. So let's start the video. Part 3. Today I will discuss about the fibrous root system. So let's start the topic. Fibrous root system. Fibrous roots arise from the base of the stem or the nodes of a horizontal stem. For example, grass plants. Fibrous roots do not penetrate deep into the soil. They begin as a single main root like a taproot system, but later on spread like a mat on the ground, with only a few roots deep into the soil. Unlike the adventitious aerial roots, fibrous roots are present underground. Leaves with a parallel venation have a fibrous root system, and the examples of the plants with the fibrous roots are, first example is palm tree. So the palm tree is also known as the Ericaceae. Next example is rice, and rice is also known as the Oryza sativa. Third example is grasses, and grasses are included in the family of Poaceae. And the next example is maize, and maize is also known as zea mays. Next example is wheat, and wheat is also known as triticum. Next example is millet, and millet is also known as the Panacetum glaucum. Next is onion, and onion is also known as Allium cepa. Next is sweet potato. Sweet potato is also known as Ipomea batatas. And the next is dahlia. Next is asparagus, and asparagus is also known as Asparagus officinalis. Fibrous roots are the type of the roots that arise from the base of a stem or the nodes of a horizontal stem, like grasses. So fibrous roots are present in the monocotyledonous plants, and similar to a taproot system, fibrous roots also begin as a single main root. These primary roots are short-lived, and therefore, as the plant develops, these roots are replaced by a large number of fiber-like roots arising from the base of the stem. So fibrous roots spread into the soil like a mat. For example, the roots of palm trees. The roots in the fibrous root system are morphologically similar in contrast to the roots in the taproot system, in which a thin, short root arises from a single thick root. Next, I am going to discuss about the types of the fibrous root system. So, the types of the fibrous root system includes the first type, which is known as fleshy fibrous roots. Just like the storage roots of the taproot system, the fleshy roots of the fibrous root system also accumulate the food and become fleshy and swollen. So the cells of the fibrous root system are modified in such a way that they can accumulate the food which is prepared by the plants and store it. Once the food is packed, the cells swell and ultimately the whole root appears swollen. The stored food is later utilized by the plants as a source of nutrition during the unfavorable conditions. So, the fleshy root system is further divided into three types, that are: first type is tuberous roots, second type is fasciculated roots, and the third type is annulated roots. Fibrous root system includes the fibrous roots as shown in the figure. Fibrous root system again includes the fibrous roots as shown in the figure. So the first type is the tuberous roots or single root tubers. These roots occur singly and give the appearance of a taproot. These swollen roots do not attain any particular shape. Tuberous roots or storage roots are enlarged lateral roots. The cells of these roots are modified in such a way that they can store food inside them. Example of the tuberous root is the sweet potato, which is also known as Ipomia patatus. So the types of the fibrous root system includes the tuberous roots or single root tubers, and the example of these tuberous roots is sweet potato, which is also known as Ipomia patatus, as shown in the figure. So the next type is fasciculated roots. These are the tuberous roots which are present in clusters. Similar to the tuberous roots, the cells of the fasciculated roots are modified in such a way that they can store food inside them. Therefore, the only difference between the tuberous roots and fasciculated roots is that the tuberous roots appear singly, but fasciculated roots appear in clusters. Examples of the fasciculated roots is dahlia, and next example is asparagus, which is also known as the asparagus officinalis. So the types of fibrous root system includes the fasciculated roots, and the example of fasciculated roots is dahlia as shown in the figure. Types of the fibrous root systems include the fasciculated roots, and fasciculated roots includes the example of asparagus. Asparagus is also known as asparagus officinalis as shown in the figure. The third type is annulated roots. These are the swollen roots that possesses the ring-like structures all over the surface. It appears like the discs placed one above the other. Therefore, they are referred to as the annulated. And the example of annulated root is the ipecac, which is also known as the Syphilis ipecacuana. Types of the fibrous root system also includes the annulated roots, and examples of the annulated root is ipecac, which is also known as the Syphilis ipecacuana, as shown in the figure. So the next type is the stilt roots. These roots are short but thick and rise from the basal node of the stem. They grow downward in an oblique direction and penetrate the soil. Once they are rooted in the soil, they develop the fibrous roots which hold the soil firmly to support the long and narrow unbranched stem, analogous to the ropes holding a pole or tent. So these roots allow better absorption of mineral salt and water. Examples of the stilt root is sugarcane, which is also known as the Saccharum officinarum. Next example is the meals, which is also known as zea meals. And the next example is Panacetum and sorghum. So the sorghum is also known as the sorghum bicolor. Their stilt roots grow in walls. And the next example is true pine, which is also known as Pandanus odoratessimus. Their stilt roots rise from the lower surface of the oblique stem and provides the support. So the types of the fibrous root system includes the stilt roots as shown in the figure. So the next type of the fibrous root system is reproductive roots. So these fibrous roots are fleshy and form the buds. These buds grow into the new plants under the favorable conditions. Therefore, the roots containing the buds which develop in the formation of a new whole plant are known as the reproductive roots. Examples of the reproductive roots are sweet potato. So the sweet potato is also known as Ipomia batatas, and the next example is dahlia. Types of the fibrous root system includes the reproductive roots as shown in the figure. So next I am going to discuss about the functions of the fibrous root system. Functions of the fibrous roots are as follows. The first function is they absorb the water and dissolved mineral from the soil. Second function is they can store food in the form of reserve material. Third function is they can also synthesize the growth regulators. Fourth example is they keep the plant attached to the soil firmly, that provides the anchorage. So next I am going to discuss about the table of types of root systems. Types of root systems, as you know, there are three types of the roots: taproots, fibrous roots, and adventitious roots. So first of all, I will discuss the column of the taproots. Taproots are prominent in dicots. Primary roots grow and become stout. Secondary and tertiary roots grow from the primary root. So the next is fibrous roots. Fibrous roots are prominent in monocots. Roots develop from the lower nodes and they have the same length and diameter. So the third is the adventitious roots. They develop from the organs of shoot system. So the types of root systems includes the three types of the root system. First is the taproot system. Example of the taproot system is the dandelion as shown in the figure. Second type is fibrous root system. An example of fibrous root system is grass as shown in the figure. And the third type is adventitious roots. Adventitious roots includes the shoot and node as shown in the figure. So the next I am going to discuss about the functions of the root system. Roots absorb water and minerals from the soil and transport them to the upper parts like the stem and leaves of the plant. The water and minerals are carried from the roots to the upper part of the plants in an upward movement against the gravity. Therefore, it requires the some force, and this force is provided by the transpirational pull due to the process of transpiration which is going on in the leaves. Roots also provides the anchorage to the plants and keep them attached to the soil by binding the soil around the roots. This is the reason why it is difficult to uproot a plant by hands. Roots are also used to store the food. For example, the fleshy roots like the carrot, radish, beet, turnip, and mirabilis. Roots also play an essential role in binding the soil, so the roots help in preventing the soil erosion and landsliding in the hilly areas. Roots of the plants like the combs, stem tubers, rhizomes, and stolon participate in the vegetative reproduction. In the some weak-stemmed plants, roots help in clinging and hence climbing roots. For example, money plant, beetle, and ivy, etc. Roots also take part in nitrogen fixation with the help of the nitrogen fixing bacteria which is present in the soil. For example, the nodulated roots of pea, bean, gram, and fenugreek, etc. So the roots of some plants are present above the ground and are known as aerial roots. For example, the pneumatophores are the type of the specialized aerial roots which are present in the mangrove plants. They help the plant to breathe. Roots of the mangrove and epiphytic orchids play a significant role in the photosynthesis. They become green upon the exposure to light and start producing the energy. There is the leafless orchid, which is also known as the Dendrophylax landinii, which solely depends upon its roots for energy production. Functions of the root system. So the major functions of the root system, like respiration and exchange of gases, as shown in the figure. Next, I am going to discuss about the difference between the taproot system and adventitious root system. First, I will discuss the difference of taproot and then I will discuss the difference of adventitious root. So, taproot, it arises from the radicle of the embryo. Adventitious root, it is formed either from the places other than radicle or its branches, for example, stem leaves. Taproot, primary root is persistent. Adventitious root, primary root is short-lived. Taproot, it is always underground. Adventitious root system can be both underground and above the ground. Taproot, there is a single main root. Adventitious root, a number of the larger roots arise in a cluster. Taproot, it can be a deep feeder or surface feeder. Adventitious root, if underground, the adventitious root system is usually a surface feeder. Taproot, main root is very thick as compared to the other roots. Adventitious root, all roots are generally fibrous. Taproot, distinction of the primary, secondary, tertiary and rootlets is quite conspicuous. And adventitious root, there is no such distinction. Difference, the taproot and adventitious root system as shown in the figure. So, in the both figures you can see that this is the primary root, these are secondary roots, this is taproot system and this is adventitious fibrous root system as shown in the figure. So the next I am going to discuss the taproot versus the adventitious root. First I will discuss the taproot and then I will discuss the adventitious root. Taproot, primary root which persists throughout the life of a plant. Adventitious root, root that develops from any part of the plant except the radicle or its derivatives. Taproot occurs in dicots. Adventitious root occurs in monocots. Taproot develops from the radicle. Adventitious root develops from an organ other than the radicle. Taproot persists throughout the lifetime. Adventitious root is short-lived. Taproot grows deep into the soil. Adventitious root doesn't grow deep into the soil. Taproot, main root of the plant from which the lateral branches, including the secondary roots and tertiary roots, are developed. Adventitious roots, a number of the roots develop at a single point. So next I am going to discuss about the taproot versus the fibrous root, differences and their examples. Taproot versus fibrous roots. So first is the basics for the comparison, then I will discuss taproot, and after that I will discuss the fibrous root. First basics for the comparison is definition. Taproot is one of the two essential root systems, where the primary root gives out the branches of the secondary and tertiary roots, growing downwards as the primary root tapers towards the end. Fibrous root. The fibrous root is the other type of the root system, where the root develops from the stem in the form of a thin and moderately branching roots without any primary root. Next basics for the comparison is evolution. So the taproot evolved from the fibrous root in the evolutionary process. Fibrous root system evolved before the taproot system. Next basis for the comparison is plants. Taproot is observed in dicotyledonous plants. The fibrous root is observed in monocotyledonous plants. Next basis for comparison is nature of the roots. The roots in the taproot system are thicker than those in the fibrous root. The roots in the fibrous root system are thin and hair-like. Next basis for the comparison is number of roots. A single plant only has one taproot, where the plants with a fibrous root system might have a multiple fibrous root systems. Next basis for the comparison is position. Taproot are always underground, so the fibrous root might be underground or aerial. Next basis for the comparison is origin. The taproot system develops from the radicle of the embryo during the germination. A fibrous root system develops from the stem tissue of the plant base. Next basis for the comparison is differentiation. In the taproot system, the primary root differentiates into the secondary and tertiary roots. All the roots in the fibrous root system arise from the stem, thus no differentiation is observed. So the next basis for the comparison is food storage. So the some taproot, like in the radish and carrot, act as a storage for the food. Fibrous roots do not store food. Next basis for the comparison is length. So roots in the taproot systems are longer. Roots in the fibrous root system are shorter. Next basis for comparison is surface area. The taproot system occupies more surface area than the fibrous root, and the fibrous root system occupies less surface area than the taproot. Next basis for the comparison is the growth in the soil. So the taproot grows vertically downwards and thus reaches deep into the soil. The fibrous roots grow horizontally in all the directions and thus doesn't reach deep into the soil. And the next basis for the comparison is the anchorage. So the taproot systems anchors the plants more firmly than the fibrous root, and the fibrous root systems anchors less efficient than the taproot. Next basis for the comparison is absorption of water. The absorption of water and minerals by the taproot is more efficient with the taproot system. So the fibrous root absorbs water more efficiently as it reaches the deep into the soil. Next basis for the comparison is drought. So the taproots are capable of withstanding the drought and the fibrous roots cannot endure drought conditions. Next basis for the comparison is the leaves, and the plants with the taproot system have leaves with a reticulate venation, and the plants with the fibrous root systems have leaves with a parallel venation. Next basis of the comparison is the examples. Some examples of the plants that have a taproot system include the carrot, mustard, radish, turnip, beetroot, parsley, and coriander, etc. And some plants with the fibrous root systems include the grasses, wheat, rice, corn, rosemary, and coconut, etc. So the taproot versus the fibrous root, this is the difference between the taproot and fibrous root as shown in the figure. So next I am going to discuss about the major differences between the taproot and fibrous root with the examples. First I will discuss the major differences of taproot. Taproot definition. Taproot is one of the two essential root systems where the primary root gives out the branches of the secondary and tertiary roots growing downwards as the primary root tapers towards the end. The taproot is the root system found in the most dicotyledonous plants and is characterized by the presence of a primary or dominant root. The radicle of the seed develops to form the primary root during the germination of the seed. However, in some plants the taproot developed during the embryonic stage is replaced by a fibrous root during the later stage. In other plants with a persistent root, the radicle develops on growing while developing the lateral roots from the main root. The shape of the taproot might differ from one plant to another, but the common shapes include the conical, fusiform, and napiform roots. The conical root is the widest at the top, tapering steadily towards the bottom. It is seen in the plants like the carrot. The fusiform root is the widest in the middle and is tapering towards the top and the bottom. It is seen in plants like a radish. Napiform root has a very wide top and tapers steadily into a tail at the bottom. It is seen in the plants like the turnip. The main or primary root might give off the branches and secondary roots, which then branches out to form the tertiary root. The tertiary root might even divide to form the rootlets. The division of the primary root into the further branches increases the surface area for water and mineral absorption from the soil. The ability to branch out and cover more areas also enables the taproot to anchor the plant more tightly and firmly to the soil. As the taproot grows straight down, it can penetrate deep into the soil and obtain the more nutrients and minerals. In some plants like the carrot, the taproot is modified for the food storage, which is then consumed as a vegetable. It is assumed that the taproot system evolved from the fibrous root in evolutionary history. So besides the plants with a taproot system usually have leaves with a reticulate venation. So some examples of the plants that have a taproot system include the carrot, mustard, radish, turnip, beetroot, parsley, and coriander, etc. So next I am going to discuss about the major differences of the fibrous root system. So the fibrous root definition is: the fibrous root is the other type of the root system, where the root develops from the stem in the form of thin and moderately branching roots without any primary root. The fibrous roots can be observed in the most monocotyledonous plants and other plants like a fern. The fibrous root system is also called an adventitious root system due to the presence of adventitious roots. The fibrous root system begins as a taproot from the radicle, but as the plant grows, the radicle degenerates and no primary root is seen. Once the plant is developed completely, the fibrous roots appears as a mat underneath the plant. The roots in the fibrous root system move more horizontally than vertically, but they cannot penetrate deeper into the soil. The roots develop horizontally in all the directions, with over 95% of the root in the top 50 meters of the soil. So unlike the taproot, fibrous roots doesn't have a primary root, and the roots are also not branched into the secondary and tertiary roots. Instead, a large number of the roots arise directly from the stem and move in all directions. Fibrous roots are considered as the surface feeders, as they do not penetrate deep into the soil but feed on the surface soil and organic matter. Fibrous root also cannot act as an organ for food storage like in some plants with the taproot system, because they are more fixed on the surface of the soil, and the fibrous root is considered crucial for the prevention of the soil erosion, as they hold the soil firmly. Besides, they can also absorb the fertilizers more efficiently than the taproot system. However, these roots might not be able to withstand the drought conditions as they have the less surface area and they do not grow vertically deep enough. The roots present are also comparatively shorter. The fibrous root system is assumed to have evolved before the taproot system in evolutionary history. So plants with a fibrous root system usually have leaves with a parallel venation. So some plants with a fibrous root systems include the grasses, wheat, rice, corn, rosemary, and coconut, etc. So next I'm going to discuss about the examples of the taproot system. So first example is the carrot. Carrot is a root vegetable that mostly occurs in orange color, even though other varieties with the different colors are available. The root of the plant acts as a vegetable and the root system in the carrot plant is a taproot. The primary root originates from the stem, which then further divides to form the secondary and tertiary roots. The secondary and tertiary roots in the carrot appears as a thin hair-like structure that is present throughout the vegetable. The root present in the carrot is termed as conical root as it is the widest at the top and tapers slowly towards the end. Carrot is an essential vegetable as it contains about 88% of water along with the other nutrients like carbohydrates and proteins. So the next example of the taproot system is mustard. So the mustard is a flowering plant that has a taproot system. The root system consists of a primary root that continues with the stem, which is further divided into secondary and tertiary roots. The mustard root is commonly used to discuss the basic concepts of the taproot system as the root grows vertically downward and has deep roots penetrating deep into the soil. So the mustard is a cool season plant that can extend up to 1 to 2 feet underneath the soil. Thus the plant can obtain the water and nutrients from the deeper part of the soil. The taproot of the mustard plant is gaining the popularity. Now it has been used as a source of food. So the next I am going to discuss the examples of the fibrous root system, and the first example of the fibrous root system is the maize. So maize is one of the essential plants with a fibrous root system, parallel venation in the leaves and monocotyledonous seeds. The root system in the maize is different from the others as it has an embryonic root system with a primary root, radical and seminal roots along with the post-embryonic root with the shoot-borne roots, termed as the nodal roots. The post-embryonic root system originates from the last few nodes within the stem, while the embryonic root develops from the radicle of the embryo. The nodal roots are present above the soil as aerial roots, and most of these root systems are fibrous root systems with the several roots originating from the same point, which do not divide further into any branches. These branches are important as they ensure that the plant remains anchored to the soil during the heavy rainfall. So the next I am going to discuss the example of the fibrous root system, that is the grasses. So all the grasses are gymnosperms with the fibrous root systems where the equal lengths of the root arise from the stem of the plant. The roots are underground that anchor the plant to the soil and absorb the water and nutrients for the plant. The roots grow horizontally in all the directions and are more or less of the same length. In some grasses, the stems grow under the soil, forming the rhizomes which help them spread through the ground. The thin and the fibrous roots enable the spread of the grasses through the stolons or rhizomes, as the roots are shorter and cannot grow deep into the soil. If you like my video, please subscribe to my YouTube channel and press the bell icon as well for further notifications. Thanks for watching. Thank you so much for your time and appreciation.